Hi, my name is Jacob Pushy, and today I will show you how to theoretically make fire with a lemon. For this experiment, we were instructed to gather a lemon, 6 copper nails, 6 zinc nails. I have zinc bolts instead because I couldn't find zinc nails. I didn't really want to buy any, so I grabbed zinc bolts, but they should work the same. A piece of rubberized wire, and some steel wool, along with some toilet paper. With these materials, we used the lemon as the medium and the 6 copper nails and 6 zinc nails in a horizontal line across the lemon in front of one another. Then we tied our wire diagonally from one zinc nail to one copper nail, diagonally, and so on and so forth. And then we tie our rubberized wire to the end nails on either end of the copper and the zinc. The copper acts as the positive, and the zinc acts as the negative. Otherwise known as the zinc acts as the anode and the copper acts as the cathode. Okay, and then we place the two ends into the steel wool, creating a short circuit as the zinc acts as the positive again, and the copper acts as the positive, much like a battery. So I am going to demonstrate what that looks like. So I tried this just a little bit ago, and I'm going to put it in the sink just because I don't want it to catch on fire elsewhere in my house. So here I have the steel wool with the toilet paper, and I tried this earlier, and I couldn't get it to work. And so I'm going to explain a little bit about that. So theoretically, electricity should be generated through an oxidation reduction reaction, a chemical reaction that occurs when zinc dissolves into the acid, the lemon. So theoretically, the lemon itself doesn't generate electricity, but when the zinc dissolves into the lemon, we create a voltage. But as you can see, this did not work for me. And I wondered how this could have possibly happened. It seemed to do so effortlessly in the video, and mine seemed to be a huge failure. So I went all over the internet and looked at why this could have happened. And after looking through articles, I found that this video could actually just be a scam. Like, it could be false. And I was shocked. And the reason for this is the arrangement of the nails and the wires in the middle connecting the positive and negative actually shorts the circuit. And in all actuality, we're only measuring the voltage of the end zinc nail and the end copper nail, just because those are the only things connected to one another. Yes, the zinc that's in the other nails dissolves into it and creates more voltage, but the only voltage that is connecting to the Brillo pad or the steel wool is the end one, and we're not getting the full. They're not connected all together. We're actually only measuring the voltage as the end zinc nail acting as the anode and the end copper nail acting as the cathode, and the lemon acting as the electrolyte, which by themselves is actually, I found to be not very much voltage at all, and certainly not enough to light a fire. Now, it does have some voltage. I saw in an article 0.5, which it does have voltage, but it's not enough to light a fire. And this was extremely frustrating for me. But a more ideal experiment would be to use the two ends and perhaps use them as a battery, because you would technically, and it's hard to see that without having like a voltage measurement. But in a video that I saw, it showed that it does have some voltage, but it doesn't have quite enough to where it could generate fire and then be combustible like that to create fire off of the Brillo pad and then sustain fire with the paper towel. So it does create electricity, theoretically. I wasn't able to demonstrate that, unfortunately, but it's not quite enough that I've seen to create fire. So thanks for watching, guys. I hope you learned a lot, as much as I did learning about this. Thanks. Bye.